All right, good morning, class. We're going to review some types of angles first, and then you're going to learn some new types of angles in vocab. One thing to know about first semester geometry, vast majority is vocab, and recognizing and putting the vocab word with the drawing. So you need to make sure when you're writing down your notes here that you're focused on the vocab word with the drawing and what they each look like. And I will continually ask definition of vocab words all throughout the semester for extra credit. So for those who learn them quicker, you're going to earn more extra credit in class. Now, there's no excuse for anybody to not get the extra credit in class if you want to. So other times when it goes by speed and some people who are quicker than others, doing their math might get extra credit. Well, vocab, anybody can learn vocab. So for those of you who might be a little bit slower with the math, you might want to learn your vocab right away and get your chance at getting more extra credit from knowing your vocab as I keep asking it all throughout the semester. Okay? And actually it'll go into next semester as well. All right, so here we go. First angle is an angle that is a 0-degree angle. Okay, so first off, notice, remember I told you the safest way to name an angle is with 3 letters. All three of these, A, B, C, they use 3 letters. They don't call it angle B, like they could in some of these cases. They use the 3 letters. It's the safest way. You'll never go wrong in doing that. Remember, the middle letter is always your vertex letter. Remember, they're all capitalized as well from last lesson. Okay, no lowercase letters for points. So a 0 angle, what it does is you have point A here. It goes in one direction of point B and comes back in the same direction. That means 0 degrees. That C could be there, the C could be in here, the C could be way over here. As long as it goes to the vertex and comes back in the same direction, that's 0 degrees. Next is acute. Acute means between 0 and 90. Remember, the word between does not include 0. You don't see an equal sign underneath either of these. It's between 0 and 90 degrees. We have the 0 angle right here, and 90 degrees has its own name, right angle, coming up next. So 1.1 through 89.999, okay, is going to be an acute angle. 90 degrees is a right angle. Here's a right angle symbol, also called perpendicular. We could say that segment AB is perpendicular to segment BC. Okay, I'm writing out the word segment, but you could, don't forget, instead of writing the word segment, you could use the segment symbol. So if you do the segment symbol like that, you don't have to write the word segment in front of it. That's a reminder from last lesson, okay, on how to name your sides correctly. Uh, I could have also called it array in this case because it is array, but I can also start out this segment AB. But if I call it array, remember I have to start with the end point, so I would say, we'll write it out here. It'd be array BA is perpendicular to ray BC. And notice I'm not writing the word ray. I'm going to go ahead and put a ray symbol above each one. And remember, the endpoint, which is B, has to be above the endpoint in the ray up here. Okay, so these are the same thing. So perpendicular or right angle forms a right angle, or they're perpendicular. Okay, so those in perpendicular and right are often interchanged. Just so you know that all throughout the year. Obtuse, between 0 and, between 90 and 180. Notice it does not include 90 or 180 because 90 we call a right angle, 180 we call it a straight angle. It's all the ones in between, 90.1, etc., up to 179.99, etc. Okay, are all obtuse angles. Okay, just so you know how degrees are done, we'll go ahead and throw that in now. You'll learn it later. This is 0 degrees right here. This up here is 90 degrees. This over here is 180 degrees. This down here is 270 degrees. And then coming back up is also 360 degrees. Okay, so 0 and 360 are the same. So notice positive direction, when it goes 0 up to 90 to 180 to 270, that's counterclockwise. Counterclockwise is positive degrees. Oops. Counterclockwise is positive degrees. Clockwise is negative degrees. I'm just teaching that now. You'll learn it later. But again, I will throw this on as extra credit, possibly on a quiz, test, or just out loud in class. Which direction? I'll just quickly say which direction is positive degrees. First one that raise your hand, I call on you, you say counterclockwise, you get the point. So like which direction is clockwise? Or what clockwise is what degrees? First one says negative degrees. I call on you. Boom, extra credit point. That's how extra credit points will go in class. So again, learn your vocab. Anybody can learn the vocab. Boom, it has nothing to do with speed. You're not calculating anything. Just learn your vocab. The faster you learn it, the more extra credit you're going to learn in class. Okay, so that's why you see, the reason I point this out, because you see here, they're always starting with 0 right here. 0 is right here, up to 90. See, 0 up to 90 for your right angle. Now here to here, 0, and then it's somewhere over here between 90 and 180. So that's obtuse. And then straight across, 0 to 180, straight angle. Okay, and then past 180, starting at 0 again. Notice they're starting here at 0, and they're going around like this. You can't see us, a little arrow down there. It's going around, so it's going from here, coming 90, 180, past 180, somewhere down here in quadrant 3. Remember, you need to know your quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Remember, we write them in Roman numerals. We don't write the 1, 2, 3, 4 like we normally write 1, 2, 3, and 4 like here. Right, in Roman numerals when you name your quadrants. Okay, so quadrant 1, if I ask you what degrees are in quadrant 1, you tell me between 0 and 90. What degrees are in quadrant 2? Between 90 and 180. What degrees are quadrant 3? Between 180 and 270. What degrees is quadrant 4? Between 270 and 360. Okay, that would be your answers as far as that. Okay, so here we see that this somewhere is in quadrant 3. Ray BA ends up down over here like this. So we're in quadrant 3 between 180 and 270. And so that's between 180 and 360, and that's called a reflex angle. It's the first time I've learned that, actually. Usually just talking between 180 and down. Okay, so reflex angle. I've never seen that on the part, but I might throw that in there as an extra credit question. Okay, see who remembers it. All right, next page. Here we have review of what we just did on that last page, vocab-wise. Okay, and our naming angles correctly. Okay, so go ahead and go through that. We'll go and do it in class. You go ahead and take your time and go through it right now, so you'll be familiar with when we do it in class. All right, same thing here. More review of vocab, those different types of angles. Okay, and you might want to put down what quadrant each one is in. I just taught you what quadrant those angles are in. Go ahead and say the name of it. Is it acute, right, obtuse? Obviously, it's right. It's not in a quadrant. It's on the axis itself. It'd be on the y-axis for the right angle, 90 degrees on the y-axis. 180 or straight angle would be on the x-axis. Okay, but acute, we know, is in quadrant 1, between 0 and 90, and obtuse is between 90 and 180. That'd be quadrant 2. So you can put that on there so that you're remembering that as well. Here, reviewing vocab, again, naming the 3 ways of naming angles here, or 4 ways if there is, and vocab as well here. All right, so now we get to some new angles. That should have been review from middle school, except for that reflex angle. Okay, so the first one we have here is vertical angle theorem, as I have written over here. It says vertical angles are equal in measure. So now the question is, what's a vertical angle? Okay, so vertical angle, if we look at it here, it's telling me that A and B are called vertical angles. So how can I describe this? Well, I look at it, I have 2 lines. Okay, so there's 2 lines that intersect, and the angles are directly across from one another. Now, how I like to remember it, what does vertical start with? V. Well, doesn't that form a V right here? And doesn't that angle form a V right here? And then they touch their vertex. They share the same vertex. So they're V's. They both form V's right here. So A equals B. And then if I call this angle 1 and this angle 3, these are also V's that share the same endpoint, that vertex endpoint here. With the rays, we're talking about rays endpoint or vertex if you're talking about the angle itself. Okay, and they're directly across. So angle 1 equals measure of angle 1 equals the measure of angle 3. So when we have two lines, we always have two pairs of vertical angles. There's a vertical angle and there's a vertical angle. That's all we have is two lines there. That's called vertical angle theorem. Okay, now on the part, just so you know, they aren't going to call it by the actual theorem names because different books use different names for different theorems, so they don't want to get the kids confused. So they'll always type out the definition of it, and that's what you'll see right here. Now, just so you know, in class, I will take either the name of it itself, you can say vertical angle theorem, or you can write out what vertical angle theorem says. Vertical angles are equal in measure. Okay, so same thing as we go all through this. Okay, again, a lot of vocab coming up here. So example, if that's 50 degrees, that's 50 degrees. If that's 130 degrees, that's 130 degrees. Okay, next one. We have the angle addition postulate. That's actually the name of it as well as the angle addition postulate. They don't have any definition written down, it's just angle addition postulate. So you memorize the name of it there. So we look over here, and here's what it's describing. If C is a point in the interior, interior means inside. So C, notice, is inside of angle AOB. Interior to AOB. Angle AOB is this whole big one. Then the two angles, angle AOC and BOC, if I add that angle plus that angle together, that equals the whole angle. So measure of angle AOB, the big angle, equals AOC. Measure of angle AOC plus the measure of angle COB. You could have called it BOC as well. Just as AOC could be called COA. Remember reviewing how you name the angles correctly. You have to be all named correctly. Okay, so interior means inside, so obviously then exterior would mean outside. It's not in this definition here, but at other points we'll talk about exterior coming up. Okay, next one. We have this drawing right here. This is called a linear pair. Notice the name of it is linear pair theorem. Okay, so what does linear pair theorem say? Two angles, notice it's two angles, not three angles, not four, not one. It's got to be exactly two angles, form a linear pair. Remember we talked about the word linear before from last class. Linear means line, first four letters here. Pair always means two. That's why it says two, not three, not one, not four, 10, only two. So two angles that form a line. Doesn't A and B, when I put them together, form this line right here? Okay, and it says, so if we have a linear pair, we have this situation right here, two angles that form a line, they are supplementary. Supplementary is the next vocab word. Supplementary means two angles that add 180 degrees. Any two angles. Now here's the difference between linear pair and supplementary. So notice it says linear pairs form supplementary angles. Linear pairs have to be adjacent. Okay, now I wrote up adjacent up here, talking about these two angles being adjacent to one another. Adjacent means next to, and they share a common side. So angle AOC and COB are next to each other, and they share this common side of ray OC. That's what adjacent means, next to. So angles A and B are adjacent. They are next to each other, and they share that common side right there. So for a linear pair to be a linear pair, they have to not only be adjacent to one another, they have to be next to each other, they have to be connected. And they form a line. Here's my line being formed. Then those two angles add to 180 degrees. That's what a linear pair looks like always. Now it doesn't have to be that angle. I mean, it could, instead of that one, it could come up over here, or it could come up here. As long as they're adjacent and they form a line, those two angles will add to 180 degrees. It's called linear pair. Now, what's the difference between linear pair and supplementary? Because supplementary are two angles that add to 180. Well, in supplementary, the two angles don't have to be adjacent. So I drew an example here. Here's an angle over here, 110 degrees. Here's an angle here of 70 degrees. Obviously, they aren't even close to one another. They're adjacent. They aren't connected, as they are right here. 110 plus 70 is 180 degrees. And there's two angles. That's the definition of supplementary. So these two angles right here are also supplementary. These two are also supplementary. They just also have to be adjacent. And since they're adjacent, they are a linear pair. So that's the difference between linear pair versus just supplementary. They don't have to be adjacent. They can be apart. Again, two angles that add to 180. Okay, next. So up here, it was only two angles that add to 180 form a linear pair. Well, here we have four angles that form this line. There's no name for that. We just know that it could be 10 angles, all adjacent. Notice these are all adjacent right next to each other. Okay, they form this line. So anytime any number of consecutive angles, consecutive meaning one right after the other, or adjacent, okay, created a line, it's going to always add to 180 degrees. So anytime we have a line, made of however many angles there are, it's 180 degrees. If it happens to be two angles exactly, then it's called a linear pair. Two adjacent angles is a linear pair. If it's 3, 4, 5, 6, 7, 8, 9, 10, etc., there's no name for it. It's just we just know they add to 180 total. All right, next. So that created a line. All these angles and these two up here formed a line. Well, what happens if it forms a circle? So we take that angle plus this angle. It forms an entire circle. How many degrees are in a circle? 360 degrees, if you didn't know that already. So this is angles at a point. So here's the point they're talking about, B. So this angle plus this angle plus this angle at point B, add to 360, just think of it as a circle right here. I drew that in there. Okay, so you can see it's a circle, 360 degrees. And that's all it's saying right there. Okay, now we get to another set of types of angles here. It says the sum of three angles measures of any triangle is 180 degrees. So A plus B plus C is 180 degrees. You should already know that. Now let's say, and we're going to go ahead and assume, let's say all three of these sides were not the same. You should remember this also from middle school. That's called scalene. All three sides are different lengths. Okay. Next one, so that's all three sides are different. Let's say two sides are the same. So I just added this in here myself. If two sides are the same, it's called isosceles. Technically, it means at least two sides are congruent. So that means if three sides are congruent, even though that's got a particular name itself, it's also isosceles. Okay, so that's why you see the word at least two sides congruent. It's usually only two sides, but there's one exception. It can have all three sides, and you can still call it isosceles, plus its actual name itself. So it says when one angle of a triangle is a right angle. Here's our angle. They didn't put that in there. They told you in words that's a right angle. So if they tell you in words, that's good to go. If they tell you as a number down here, that's good to go. But you should always look to draw it on your drawing. There's my right angle symbol. It says measure of angle A, so I should put a right angle symbol there. If that's 90 degrees, it's a right angle, which means 90 degrees. We already reviewed that. The sum of the other measures of the other two angles have to add to 90. Why is that? Because all three angles add to 180, right? If I subtract off that 90 degrees from the total of 180, that leaves me 90 left for these two angles to add up to. Okay, that should be common sense. If that's 90, then these two have to be 90. Now, any two angles, they don't have to be adjacent, because these are not adjacent. Any two angles that add to 90 degrees are called complementary. Okay, remember we had two angles that add on the last page. Two angles that add to 180 degrees are called supplementary. So that's the two words. You have supplementary, two angles that add to 180, and complementary, two angles that add to 90. Not one angle, that'd be a right angle. Not three angles, four angles, five angles, only two angles. Add to 90 called complementary. Okay, so if I have two sides are congruent, remember how I show sides congruent? I use these hash marks. The same number of hash marks means those sides are congruent. Remember, congruent means equal. Okay, so these two are equal. Then that's called an isosceles triangle, but we also know it's a right angle there, so we call this an isosceles right triangle with the most specific name, naming this particular triangle right here. Later on down the road, we'll get into naming different shapes, whether it's quadrilaterals, etc., different names of them based off of what we know. So knowing that, this is called an isosceles right triangle. Now, you ask, what are these right here? Well, in an isosceles triangle, if I have an isosceles triangle, first off, where the angle that the two congruent sides come to, so this side and this side come to this angle A, this is called the vertex angle. I wrote that down in another one right here, right down here. See, here's my two congruent sides that come to it. That's called the vertex angle. The side opposite the vertex angle, here's my side opposite the vertex angle, that's called the base. Okay? And then the two angles on the base, what do you think they're called? Base angles. Okay? So, coming back up here, this is my vertex angle. These would be my base angles. If I have an isosceles triangle, as I do right here, because I made an isosceles by putting hash mark on each of those, so now it's not isosceles. If I have an isosceles triangle, then the base angles must be equal. That is called the isosceles triangle theorem. Isosceles triangle theorem. Base angles are congruent in an isosceles triangle. Okay, so that's called the isosceles triangle theorem. You don't have to know that because, again, the name you can either choose and remember the name isosceles triangle theorem or just what it says. Base angles are congruent in an isosceles triangle. That's what it'll say on the part, where they're going to write out the definition, not the vocab word itself. Okay, so how do we show that the two angles are congruent? We use arcs. So that, I don't think I've talked about that yet. And whether your middle school teacher taught you that, I don't know. Okay, depending on how far ahead they taught you. So we show sides are congruent by hash marks. We show angles are congruent by arcs, the same number of arcs. So that's got one arc, that's got one arc, they're equal. Since these two we know add to 90, they're called complementary. Well, since they're equal, we can say that's x and that's x, and we get x plus x equals 90, so we get 2x equals 90. So then both of these have to be 45 degrees. Okay, so anytime you have an isosceles right triangle, the two base angles here are 45 degrees. Okay, some more vocab. Now remember, just like supplementary, just any two angles add to 180. Complementary, any two angles add to 90. So here's an example. Here's an angle over here, 30. Here's an angle over here, 60. Those two add to 90, so they would be complementary angles. They do not have to be adjacent. They don't have to be touching. Okay, next to each other. Share. Remember, adjacent means next to. They're not next to. All right, so I told you we're going to come across the word exterior. Here we have it right here. The sum of each exterior angle of a triangle. So how do you come up with an exterior angle? You have a triangle here and you just extend one of the sides. It doesn't matter which side, they just happen to extend this side. So this is called the exterior angle because it's outside the triangle. Okay, so angle 1, or we call it angle ACB, D, or angle DCB, either one. So you have three names right there. 1, BCD, or CDB, the DCB. That's the exterior angle here. It says this exterior angle equals the sum of the two opposite interior angles. Okay? Opposite means across from. So these are two angles that aren't next to angle 1. And they're interior, inside. They're inside the triangle here. Okay? So angle 2 plus angle 3 equals angle 1. So if this is 50 degrees and this is 60 degrees, then this is 110 degrees. 50 plus 60 is 110. Then angle 1 would be 110. That's a plus right here. Okay. So remember, they used BAC. They could have called it CAB, and I called it 2 there. I could have put an angle 2 there. And then they call it ABC. Could have called it CBA, or angle 3 as I put in there. Equals BCD, or angle 1, or DCB. Okay, that is called the exterior angle theorem. Okay, that should be easy because it's exterior outside angle. Okay, so it makes sense. We're talking about an outside angle here. Now, again, on the part, they're going to write out the definition. They're going to say exterior angle theorem. They're going to say exterior angle of a triangle equals the sum of the two opposite interior angles. They may say two opposite interior or remote interior angles. That's an equal sign. Opposite equals remote. Okay, so if I ask and I give you the definition. I say the exterior angle of a triangle equals the sum of the two opposite interior angles. Now I might ask and say, well, what's the other name for opposite? And then first person raise your hand says remote extra credit point. Okay, memorize your vocab here. Okay, next one. We have base angles of an isosceles triangle are equal in measure. So we already talked about that right up here. Now we officially see it right here. So base angles, so you have to know where the base angles are. Remember, the vertex is where the two congruent sides come together. The base is opposite that vertex angle. There's the base, so there's the base angle. So it's saying, if I start with an isosceles triangle, the definition of an isosceles triangle is at least two congruent sides. So I put my two congruent sides right there. If I have that, then the two base angles must be equal. One arc and one arc showing the same number of arcs, showing they're equal. So base angles of an isosceles triangle are equal in measure. That's the isosceles triangle theorem, which I pointed out up here. Okay. Next one, all angles in an equilateral triangle have equal measure. So it's an equilateral triangle. Equa means equal and lateral means side. So equal sides. So if I have all three sides equal, that's an equilateral triangle. If I have an equilateral triangle, then all the three angles must be equal, and that's called equiangular. Equal angles. All the angles are equal. Well, since we know, we can figure out what each of these angles is. So we know all triangles add up to 180 degrees. So we have x plus x plus x, or 3x equals 180 divided by 3 on both sides, and x is 6 degrees. So every angle in an isosceles, not an isosceles, in an equilateral triangle is 60 degrees. All the angles are 60. All the angles are in equilateral have equal measure. They could have said all angles in equilateral triangle are 60 degrees. It's always going to be 60 degrees. Okay. And last page here. Now this is some newer stuff. Again, the quicker you learn it, the better. But this we'll get into in maybe a few days. Okay. After we learn constructions, I'm going to just show you now. Okay. So over here, it's describing what it is. I've written down the name of the theorem or the postulate over here. Okay, and then here's the definition again. Remember, that's how it's going to be on the park. They'll write the whole thing out, the definition on the park. But in class, on a quiz or a test, you can name it just by this postulate theorem, or you can write out the whole definition, summarizing it. Okay, you need to know both. Well, you need to know both because I might say in class for extra credit, what's the name of that? At least memorize the definition because that's how it's always going to be on the park, is by the definition. Okay, so it says, if two parallel lines are intersected by a transversal, then corresponding angles are equal in measure. First off, if you have an if-then statement, that's called a conditional. C-O-N, if, then is called a conditional statement. Vocab. Okay, so all of these are if-then are conditionals. They're all if-then statements if you look down this page here. It's called a conditional statement, just so you know that vocab. The part after the if, up until the comma, before the then is called the hypothesis. And the part after the then, it does not include the then, just like the hypothesis does not include the if. The part after the then, till the end of the sentence, is called the conclusion. Again, vocab, you might throw that on as extra credit. Okay, they used to have it in our old geometry books, and you did it regular as your test. They haven't focused on that as much, but just in case somehow they throw it on there for review information. This is called a conditional. The part after the if is hypothesis. The part after the then is called the conclusion. So the hypothesis is what we are assuming to be true. So if I have two parallel lines intersected by transversal, how we show parallel lines is we use arrows on the lines, and they go in the same direction. It's the same number of arrows. I could add 2 arrows and 2 arrows, and that'd mean these are still parallel. It's the same number. The transversal is the line that cuts through those two parallel lines. So this is the transversal. So notice they'll talk about it all the time. So if two lines are intersected by transversal, two parallel lines are intersected by transversal. That's always the same situation right here, same setup. So if we have two parallel lines cut by transversal, then we can say corresponding angles are equal in measure. So that is called the corresponding angles postulate. So now the question is, what's a corresponding angle? Notice they gave you this one and this one. So corresponding angles, notice they are on the same side of the transversal. So this angle and this angle are on the same side. It could be on this side or it could be on this side. They have to be on the same side. And one angle is interior to the parallel lines. That one's interior. And one angle is exterior to the parallel lines. And notice they are not adjacent. So this is an interior and that'd be an exterior, but those are adjacent. So we can't do that. One's an interior angle, one's an exterior, and they're not adjacent, and they're on the same side. Those are called corresponding angles. Okay, you got to memorize that, corresponding angles. So if I have parallel lines cut by transversal, then corresponding angles are congruent or equal in measure. So there's one pair of corresponding angles. There's the next pair, interior, exterior, on the same side. Notice I have two arcs there because they're congruent, and they don't have to be the same measure as these ones. Okay, then I went ahead and used my vertical angle theorem. If that's two arcs, then this is two arcs, these are vertical angles. If that's one arc, then this is one arc because those are vertical angles. If that's one arc because those are vertical angles. And I have the two arcs there, then there must be two arcs there. Those are vertical angles. So learning using the vocab we've used here. And now notice we have another pair of corresponding angles. Again, one interior, one exterior on the same side. Here's another pair. One exterior, one interior on the same side and not adjacent. So we have four pairs right here of corresponding angles. You'll get into that and work on naming those different pairs later on. So we're not focused on that right now, just so you know what they look like. Next is called the converse of the corresponding angles postulate. So it's almost the exact same. The difference is converse of. Okay, converse means to switch the if and the then. So that's what they've done here. This if became here, and this then really came up here, and they reworded it then. If two lines are intersected by transversal such that a pair of corresponding angles are equal. So now if we know that these corresponding angles, one pair, are congruent, then the lines must be parallel. That's what this is saying here. If I have corresponding angles equal, then these two lines are parallel. Notice on this one, I started with parallel lines. If I have parallel lines, then I can say the corresponding angles are congruent. This is the converse. If I have two lines cut by transversal and corresponding angles are congruent, then these lines must be parallel. That's what that's saying. Then the lines are parallel. It's called the converse of the corresponding angles postulate. You'll see that converse of on each of these here, which switch in the if and the then. Okay, so next type we have, again, we start with parallel lines cut by transversal right here. Okay, this is then, if we know that's true, we already know corresponding angles are congruent. We also know interior angles on the same side of the transversal are supplementary. So I usually call it same side interior angles or supplementary instead of saying it as is right here. So when we get into this in more detail, I will change it and say same side interior angles are supplementary. So what does it mean? Same side interior angle, same side of the transversal, just like on the corresponding angles, they're on the same side of the transversal. These angles are on the same side of the transversal. We also have a pair over here. These two are also supplementary. Now it says then the interior angles. So notice they interior, both angles, plural. Both of them have to be interior. That means inside the parallel lines. Can't be outside at all. Those are exterior angles right here. Interior angles, these are the four interior angles. Out here, 1, 2, 3, and 4 be the four exterior angles outside the parallel lines. Okay, so same side interior, same side of the transversal, and they're both interior angles. They're not equal like up here, they are supplementary. And what does supplementary mean? Again, two angles that add to 180 degrees. We did that on the last page. Right over, let's see, what do we have it here? Supplementary. That's complementary. So what is it on the previous page here? Supplementary right here. Two angles that add to 180. Okay. So this angle plus this angle adds to 180. And then we have the converse of that. Remember, this one we start with parallel lines. This one we say, if we know that angle plus that angle adds to 180, then these two lines must be parallel. The converse of the same side interior angles theorem. SSI, same side interior. Okay, that's a shortened version of right now the whole word same side interior angles. I'll show you how you can shorten some of these if you want. Again, on the park, it's going to write out the whole definition. So you need to be familiar with these definitions and be able to put it to that. This is just a shortened name for it. Okay, and the last pair that they're going to show, there is another one that we'll get into later on when I talk about this in more detail, but they're only showing you 3 so far. Again, we start with if we know we have 2 parallel lines cut by a transversal, then alternate interior angles are equal. Alternate means diagonal. Boom, diagonal across from each other, not on the same side, otherwise it would say same side. Alternate means diagonal. Know that vocab. So then the alternate interior angles, plural again, both of them have to be interior angles. They can't be out here or over here because those are exterior angles. They have to be interior angles. So there's one pair, alternate interior angles. Here's my other pair of alternate interior angles. Both alternate mean diagonal and they're both interior. Alternate interior angles are equal. So if that's 50 degrees, that's 50. That's 100 degrees, that's 100 degrees. Okay? So if parallel lines are cut by transversal, then alternate interior angles are equal in measure. The name of that theorem is the AIA, alternate interior angles theorem. Okay, alternate AIA, alternate interior angles, AIA theorem. This is the definition. And then lastly, just the converse of it, just like we did the converse before. Converse, switch the if and the then. So this time, instead of starting with parallel lines, we're starting with alternate interior angles being equal. So if we know the alternate interior angles are equal, if one pair of alternate interior angles are equal, then those 2 lines have to be parallel now. Converse of. So to remember this, anytime you're going to use converse of, you are proving lines parallel. That's what you're trying to prove, is that the lines are parallel. If you start with the lines being parallel, then you're proving that the angles themselves are either equal or supplementary. Now, one way to know, and the other 4th one that you're going to learn, those angles are going to be equal as well. So there's only one of them that is supplementary, one pair that's supplementary. It's easy to remember. What's the word supplementary start with? S. What are these 2 angles called? Same side interior. They start with what? S. Same side, S, S. So the same side interior starts with an S, then it's going to be supplementary. All the other types that you're going to learn, these 2 plus the last one, are going to be equal in measure. Okay, and that goes ahead and covers it. So again, reviewing the 3 types of angles so far with parallel lines corresponding, the first one. Okay, then we have same side interior, and then we have alternate interior. Those are our 3 types, and that will end this lesson. Have a good day. Bye.